All right, so the next type of transformation we're going to look at is a reflection. Now, there are two types of reflections. The first type is a horizontal reflection, and the second type is a vertical reflection. So in this lesson, I'm going to introduce to you the horizontal reflection. So let's go to the next slide here. Let's take a look at the first statement that I have up top here. It says, when the graph of y is equal to f of x is transformed to the graph of y is equal to f of negative x, so notice the difference there, there is what we call a horizontal reflection. So if you take a point x, y on any type of function, okay, could be quadratic, could be cubic, could be quitic, it really doesn't matter as long as it's a function. If you take that point and you graph it or you transform it to the graph of y is equal to negative x, it's quite simple. What ends up happening to that point is that your x coordinate becomes a negative. So my point xy becomes negative, comma, y. All right, so your x values all become negative, your y values all stay the same. Okay, so we're going to perform a horizontal reflection on this given graph down here, which is a simple linear graph. Okay, so when you perform any type of transformation, it doesn't matter what it is, the first thing you want to do is pick 3 or 4 good points. Okay, so I'm going to pick this point right here, 6, 9. Okay, I'll pick a second point at 4, 5. Okay, I'm actually going to pick this y-intercept right here, which is at 0, -3. And I'll pick one more point at negative, let's see, right there, -2, -7. Okay, so we're going to take each of these points and we're going to perform a horizontal reflection. And remember, what happens to the points? Well, the only thing that changes are the x coordinates. They all become negative. So my new points are as follows. The 6, 9 becomes -6, 9. All right, 4, 5 becomes a -4, 5. All right, and it keeps going. 0, negative of a 0 is just 0, 3. All right, so notice these points didn't actually change, did they? So proceeding on, the negative of -2 is +2. So +2, 7 is my last point. So we're going to simply sketch these points on the graph and connect them. So -6, 9 is right there. -4, 5 is right there. 0, 3 is right there. And 2, -7 is right there. Okay, so let's connect the dots. Remember, it's a linear graph and you want to keep it that way. So connecting the points, we have a linear graph going down just like that. So there is a transform function. It's a reflection of this red graph in the y-axis. So notice that the y-axis acts like a mirror. Okay, so it's being reflected in that line. Okay, also notice what happened here. We had a point that didn't change under our transformation, and that point is right there. That is the y-intercept, right? So what can we conclude? The y-intercept is invariant. And remember, an invariant point is a point that stays the same under transformation. So stays the same. All right, so that's a concept from 20-1 actually. So it's coming back. It's in 30-1. It's a pretty simple idea. Invariant point is a point that stays the same under any type of transformation. So in a horizontal reflection, you can conclude that the y-intercept doesn't change. So it's called invariant. And so that is my lesson on a horizontal reflection.